Data on the plane is at it again. Now, if you're not familiar with him, he's the guy that literally makes stuff up, like this gem here. Since our eyes have a constant 1.22 angular resolution, now I always thought that if you had 20/20 vision, which is very good vision, you were able to resolve things down to 0.0167 degrees. But anyways, let's listen to Data on the Plane with his latest claim. Now he has no commentary, he just plays music, and that looks pretty conclusive to me. Now I would have to assume that Data on the Plane has never bought lumber before because you don't look down on something to detect curvature. You look along its length. Now when I look down on the top of this 2-foot wall, it looks flat, just like the sidewalk does. So let's see what happens when we look along its length. Now you can already clearly see that it is not perfectly flat at all. Now you can clearly see that there is a high point here. If you even look along this little stretch, you can see that there are some small up and down undulations. And if I would have zoomed in on that, you would have seen the same thing for the whole length of this wall. So surprise, surprise, looking down, curvature not visible. Looking along the length, curvature very apparent. Now we downloaded Blender, which is 3D software similar to AutoCAD, and Blender allows you to go to various maps and download elevation data. Of course, I don't think that Data on the Plane understands that elevation data does not include Earth curvature. Elevation is basically based on mean sea level. Now, there's currently a lot of talk in the flat Earth community lately about water levels and level lines. And they are under the delusion that if you have a series of water levels, they would mark the same elevation above flat Earth mean sea level. And therefore, a level line would be a straight line parallel to mean sea level. Now we have a similar hypothesis in the globe. The only difference being is that a level line would be a curved line of the same elevation above the curved surface of globe mean sea level. So the reality is the elevation of these three hills would be exactly the same on both models. The only question is, do we live on a flat Earth or do we live on a globe? And of course, that Lake Pontchartrain Bridge is pretty good evidence of a globe because that bridge deck is a constant 16 feet above the lake, except for the marine overpasses that you see. Therefore, that bridge deck is a 16-foot level line. And I don't know about you, but it looks quite curved to me. So he's downloaded these elevations, and along the perimeter you can see he can really exaggerate the elevations. But of course, Data on the Plane overlooks something. And what he overlooked was this Cartesian coordinate system. So Blender is actually basing all of these elevations on his map on the XY plane of this coordinate system. And that is a flat surface. So yes, you can see elevation changes of these overpasses right here. So I have to assume he was able to find some map information that included these elevation changes of these marine overpasses. But again, this is an elevation change. This bridge deck is a constant 16 feet above the surface of the water. That is not an elevation change. This is curvature. So again, since the elevations are based on the XY plane of Blender, which is a flat surface, why would you expect to see any curvature? Now the funny thing is, flat earthers always say, trust your senses. But of course, that is until reality tells them to ignore what they see. And suddenly it's quite alright to use CGI to explain it away. So what else can I say?